Good evening, everyone. Can you hear me?
Yes.
Thank you. So just waiting one more minute and let's see if more students can join the class. We have over 200 students, at least 5% made it. That's great. So good evening, all of you. And today we are going to start about 520 BADM 520 course. Thank you very much for your hard work that paid off and all you are into 520. This course is easier as compared to the previous course because you are in rhythm. You already understand the concept. Now we are going to apply here in real situations with real data and real problems, or some problems based on data. So let me start about syllabus. So as usual, we have divided our syllabus. I think these things very common that you have used in past class. This is my office here in Catalyst in Spokane. It is very close to downtown. If you are in the city or around Spokane or in Spokane County and few concept you are not able to understand, you can always welcome in my office with mutually available time. So instead of online, you can also stop by my office. Most of the time I work from office, and you can send the email and I will try to reply your email as soon as possible. And that you already experienced in past class. So vision mission exactly the same, since now it requires BADM 503 or equivalent knowledge. So few students directly coming into this course, they must refresh their knowledge from chapter 1 to 9, because few concepts they will not understand. So basically I would request them or just ask me, so I will try to share some links, some information, so you can understand, those who are directly coming into this course. Now what we are going to cover, this is what we are going to cover. We are going to start with decision tree, probability decision tree based theorem. Then we are going to see the in last class we studied one sample hypothesis. Now we are going to check two sample, and we are going to see many sample using ANOVA also. Then we are going to, oh, screen is very small. Oh, this is Word. Now how is this? So I made it full screen, or you want, I can do this. Is it clear? So we are going to learn decision tree based theorem hypothesis testing and quality tools and techniques, multi-criteria decision making, time series forecasting, multiple regression. That is what we are going to learn. And everything is, we are going to use 7th edition of Duane and Seabird, which is right there. So basically here you can see, you can get the book. Those who are new into the class, they can just log in into their Canvas, and on this side, my textbook is right here. So we will be using Minitab as our tool and Excel. Second option. Second thing is Excel, because all the items or all analysis cannot be done in Minitab. Minitab doesn't have the first module and sixth module options. Therefore, first and sixth, we will use the Excel. So how to install Minitab? Most of you know because you are already working. but those who are new, please let me know. I will share and I will explain later. So Minitab is one of the tool that we use. Let me go briefly here. Or just a minute. Okay. EW Minitab. So this is something I will share, the link to you. Uh, just go on this. I was using till yesterday, but so here, this is the link, and you can use, no, this is Microsoft, but I will let you know later. So Minitab, most of you are using. This week, we don't use Minitab. We are going to use Excel. And from next week, we will be using Minitab. So next module number 2, 3, 4, we will be using 2, 3, 4, 5, we will be using Minitab, and last we will use again Excel. So we have all the options you can install on your Windows computer. If you are using a Mac or Chrome, you can use the cloud version. And the third option is Amazon Web Services. Here now we have equally divided 4 parts of evaluation in the course. So these 75% grades are based on your practice, based on your learning. You can earn all of them, 75 out of 75 very easily. Exam, those who practice, do, learn, for them 25% is not big task. We will have 40 question mixed of multiple choice question and fill in the blanks. So this time discussion is going to be very important, and you have to do very critical analysis in discussion. You will see the contemporary topic in discussion, contemporary issues related to the subject matter, and just research, think, share. So same option, like 15% daily penalty as per here. People say, or students say, that why I count only last option? Why don't I count the highest option or highest score? The reason is that these are multiple choice question. In 5 minutes you can finish 10 times these questions and something will be high. Therefore, I would like you to think, work, learn, and do. Last attempt will be counted. So please always do the last attempt fully in order to get your score, and do it before due date. So final exam will be on 26th of March 23. So please note this time because this day we will have the exam. And this is uniform. So basically nothing extraordinary here. Exactly the same way we did 503. Any question related to the syllabus? If you don't have the question related to syllabus, I'm directly jumping into the probability part. So we have 5, 6 modules. The first module is about probability, conditional probability, chapter number 5 of the book. Module 2, which is based on 2 samples hypothesis testing. I believe this is chapter number 10, and it will also include the 11, which is ANOVA. Multiple regression is chapter number 13. time series, if I remember correctly, chapter number 14. Quality tools and techniques, I think this is chapter number 17. This is a additional thing that nowadays required for every decision maker to learn about earned value analysis and multi-criteria decision, which is based on many criterias to make the decision. So this is external, which is not from the book, and I will put some reading material here, and I will also explain. So this is comparatively, much easier than previous course. Now let me go into module 1, which is probability. So as you know, what is the probability? I understand probability of, chance of any event, likelihood of any event. So if you do any experiment, random experiment, what are the chance of getting the result? So same thing is probability. This is based on conditional probability, means condition is given and then we are going to see the probability. There are 3 types of probability which I will, tell first. Empirical probability, classical probability, and subjective probability. And our discussion is based on this. This big discussion, there are 2 questions. If you feel that 2 questions are too much, I can remove the second question and you can just focus on one. I can put that question in the later section, or no, Mandy, this is the separate. You are done with the 503 and nothing will be carried on here. So this is all based on whatever we are learning here. So empirical probability, that is based on the data, estimate from frequency, observed outcome frequency. And classical, that before you are doing any experiment. Let's say if you are flipping the coin, there is a 50% chance of getting head or 50% chance of getting tail. So classic, or if you are rolling a die, you have there is a 16.6%, 67% chance of getting one. Subjective probability based on the expert's opinion, based on the judgment. So all you are working in industry and you have greater insight about industry, and the metaverse is a new technology which is knocking the door of all the industries. That can be very valuable for the industry if they exploit it properly. So based on your subjective and empirical, what is the value, and that is what you have to discuss in the this week discussion. So 3 types of probabilities. Here, what is probability? There are 3 ways of assigning probability. Now here, please mute your microphone. Now I come on, few exam. So let's say, what is sample space? If you roll two dice, 1 to 6, 1 to 6, what is the sample space? I please Mana, would you please mute your microphone? Okay, thank you. So if you are rolling a 2 dice, the sample space is going to be 36. So this is the combination. Now, what is the chance of getting 6 when you roll 2 dice? This is a classical probability. When you are getting a 6, you can clearly see here. This is 6. this is 6, this is 6, this is 6, this is 6. Do you think any other place you are going to get 6? 1, 2, 3, 4, 5. I think one more place somewhere you can see, or so. So you or 7, 1, 2, 3, 4, 5, 6 places. So what is the probability of getting 7? 6 divided by sample space, 36, which is 1 divided by 6, and you can get the probability. Now, probability value can be between 0 to 1, and it can be 0, can be 1. 1 means 100% chances of any event to occur, and 0% chances of event to occur means there is no chance of event to occur. So the probability of an event is a number that measure a relatively likelihood or chance of any event to occur. So it can be 0, it can be 1, it can be anything in between. Probability of all the events in the sample space is 1. Let's say in a store, people pay through credit card, people pay through debit card, people pay through cash, people pay through checks. So 35, this is different numbers given by different, but total sum is sample space is 100. These are different mode of payments. So sum of all the events in a sample space is 1. So basically you understand the concept, what is probability. Now I'm directly jumping into some example. If you have large number, if you do the experiment large amount of time, the probability will be like uniform. For example, if you are flipping the coin 10 times, this is the graph. If you are flipping it 200 times, this is going to be it is classic approach, empirical approach. So I'm subjective approach. This is very important. Our discussion is based on that. So this probability reflects someone informed judgment about likelihood of an event to occur. It is used when there is no repeatable random experiment. For example, what is the probability that new truck product program will show a return on investment at least 10%? The same question, same kind of question I ask about metaverse. What is the probability that price of food stock will rise within next 30 days? Now we are coming on the rules that please understand. Once you understand that, you will solve any problem. So this is a probability of event A. This is denoted by here. Probability, and this is the rest of the area is in this Venn diagram. You look, this is the event A. Then rest of the area is explanation mark, or this is the complement of an event A is denoted by this. So event A complement A by A dash, or complement of A, sum together is 1. So this total is the sample space. This is probability of event A. This is then rest of the space is A complement. The sum of both is 1. So probability of A complement, total is 1, and then subtract this one. This is simple arithmetic, no extraordinary things. Now, if you do 2 events in the sample space, if you have these 2, A and B, and union is denoted by U, or in word, or. Please remember, this is or symbol. These both are same. The union of 2 events consists all outcomes in the sample space as that are contained either in event A or in event B or both. And what is the formula for this? So here, this is, then we are going to learn this next. This is intersection. Intersection means common area between two events. And it is, yes, PowerPoint is in module 1 and I can show you right here. So if you go under this lecture material, under this, you can download the PowerPoint from here. Every module. So this is a common area. And this is common area is called end. And it is denoted end, or it is, up, this is the symbol. It's, so the probability, this is called also joint probability. Joint means common. Now we come to the very important formula that you can remember. Probability, what is the probability of A or B? Probability of A and the symbol or B. Probability of A plus probability of B minus probability of A and B. Why we are subtracting one A and B? Because if you remember, if you see this, this is 1, this is 2. And then when they, so this area is overlapping with each other, or I would say this area is overlapping with each other. So the area, this is going to be, let's say, I'm sorry, I'm not able to make. So one time it has to be subtractive because, this is coming from two areas. So therefore, this common area has to be subtracted one time. So this is a formula, probability of A and B equal to probability of A plus probability of B minus P, A and B. So this is very first important formula. And now based on this question is here. So if you have a deck of cards and probability of queen is, what is probability of queen? There are 4 queens, total number of cards are 52. This is a probability of queen. What is red probability? There are 27 red cards out of 52. What is the probability of red and queen? 2 divided by 52. There are 2 cards which are red and queen. So now probability of queen or red. What is the probability of queen and red equal to probability of card plus probability of queen plus probability of red minus probability of queen and red. 4 by, then you can subtract and, do it simple and you get the answer. Similarly, if we do the same question in terms of real practical thing, what is the probability that people will pay through, in many stores, people pay few amount cash and few amount, part of amount using credit card, cash or credit card. What is the probability that, in a store, it is paid by cash or credit card? So that end of the day, you can check, and you can get to know that how many people paid through cash, how many people paid through credit card, and how many people paid cash and credit card both. Then you can get to know the probability in your store. That, so you need to install the cash deposit machine in your store if you have enough probability of that kind of thing. So I hope you are understanding what I'm trying to say. Maybe then I'm not talking mutually exclusive. If they are not coinciding, then, they are separate, and then common part is 0. Therefore, we are not subtracting. Probability of A or B equal to this minus. There are conditions, but we are not going to learn this. Now we are going directly into the conditional part. Look into this. Probability of A condition B. Probability of A condition B equal to probability of A and B divided by probability B, where probability of B is greater than 0. So it is very simple. This is a common area. This is the only probability of B, and you do this simple arithmetic and you can get the answer. And so it is nothing but, probability of this from denominator, probability B is shifted here. Now here, this is the example, and 13.5% people are unemployed, 29% are dropped, high school dropout, unemployed and high school dropout is this much. Now they are asking question, what is the conditional probability that member of this population is unemployed given that person is high school dropout? So the condition is given that person is high school dropout. How do we do? I mean, we can do this very simple here. So probability of unemployed, probability of dropout, probability of unemployed and dropout, all three numbers are given. Now, using the same situation, probability of unemployed condition drop. And we know what is the probability of unemployed and drop divided by probability of dropout. So you just do, and you can get the value that, those who are high school dropout, the probability of unemployment, given that they are high school dropout, is 18.31%. So this way we can do a lot of, we can estimate a lot of things in business decision making if you have the data. I'm coming with real data. So this is, now let me explain the contingency table. What is contingency table is nothing but a cross tabulation, and I can explain through whiteboard, very simple. So I hope you can see my whiteboard. Can you see my whiteboard? Okay, perfect. So let's see, we have 210 students in this class, and I divide these 210 students in, I can, do like this, female and male. I can divide into three sectors. With working sector, one is service industry, one is manufacturing industry, one is agriculture industry. And now there are like, from service industry, we have 80 female who are in this class and 20 male, which is 100. I have, in manufacturing, I have 30, or let's say 50 male and 20 female. I have, let's say, so agriculture, I have 10 female. What is the left? 80 plus 20, 100, 170 and 180. Now I have 30 more. So now I can do it. This is 100. This is 70. This is 40. And this is, so now I know how many people in service sector, 100, manufacturing 70, agriculture 40. Similarly, I can, how many male, 20 plus 50, 100. And we have 110 females. now we make our cross tabulation. This is called contingency table, and total, is 210. Now question comes, what is the probability of male here? Probability of male. Can anyone tell me the answer? Probability of male? The number
100 divided by 100.
100 divided by 210. The reason, this is a sample space, so we need to divide with sample space, and this is the total male. This is called, so this is called, so I have to look into, this is joint so these are called joint. So this is called, I forgot the exact name of marginal probabilities. Yes, thank you. So these are called marginal probabilities. Thank you. And where I was on whiteboard. So this is marginal probability. Similarly, I can do this. Now I ask, what is the probability of female working in service industry? Then how I can calculate? So basically the formula is probability of female and service divided by probability of service. Now look into the what is probability of female and services. This is the 80. 80 is the just common number, but when you do the probability, we have to do by 2 by 10. So this is the probability of female and services. Now probability of services, how much? Probability of services is 100. So 100 divided by 210. So 210 is cancelled. 80 by 100, which is 4 by 5. So you can get the answer here. So this is probability of this. Now similarly, now I ask, what is the probability of female or manufacturing? Then how will you do? Probability of female plus probability of manufacturing minus probability of manufacturing and female. So if I write probability of female and manufacturing, or I write probability of manufacturing and female, they are all, sorry, please bear with my, I'm just using mouse. They are same because, the common area, common is same. So probability of this, same. So you can just put 3 numbers and you can calculate this. So contingency tables, this is called joint probability. This is called joint probability. This is called marginal probability. This is called conditional probability. How do we do? I gave the example in our, fill in the blanks questions. So let me show my whiteboard and then. Okay, here we go. So this is a Titanic data I shared with you, and you are going to do the probability difference. So what I'm going to do, I'm just going to select all the data in real life. How, if you have customer data, if you have partners data, stakeholders data, or different, different data, how you can use conditional probability and know the chances of event to occur in real business decision making. So I just use the same data that we worked in 503. So this file is attached. So I'm just selecting all of them. And here you know how to work with pivot table. Here we have pivot table. I just selected this. You can choose new worksheet or existing worksheet. So let me do with existing or location, then I can select here. And now I have the pivot table right here. Now, here you on the right side, if you are looking my Excel, I can do that. You know, this is, for example, the class. And now I'm going to do join. And I'm going to do the values here. And if you can see, so you can see based on the question, you can make your pivot table. This is 2D, two dimension. But you know, there's a power pivot and different other pivot tables. If you go in this Excel, power pivot is also available. We are just learning basics. So here you can see the table is given. Total number is 2,478. The city from where they joined 415. This city, Queenstown, Southampton. You know, the different classes: first class, second class, third class, C class, S class. And now you have the contingency table in order to answer the question. So first, anything, what is the probability of Queenstown and C class? Can you see, or let me make it much bigger? Okay, I hope now you can see it better. So let me, okay. So now, what is the probability of Queenstown and C class? Zero, exactly, because you know there is no common thing, common. But if I ask what is the probability of C and Belfast, you can clearly see 401 divided by total sample. So 401 divided by 2478. So different questions I asked related to this, and in the final exam also you will get that contingency table like this. You will be asked to share different question, and you need to give the probability. So now let me go further. So marginal probability, you know, in the slide, this is a publisher slide. Some slides are little different, like, you know, slide number 38. This is the find the probability that salary gains are small, given that MBA tuition is large. So S1, and we would like to S1 condition T3, we have to look this opposite. It is given T3 and S1. So, you know, the numbers are given correct, but you know, this formula has to be like, you know, this should be before, this should be later. So please check, you know, few things are marginal, conditional probability, joint probabilities. So different probabilities are there. So this is the example, which is, so contingency table, you understand. And now this is very important application that is here. Applying the rule of independence, and it can be very useful in real decision making. What does it say? So you can see here, if you do multiple independent, let's say I'm giving an example of Amazon. So Amazon needs to run 24/7 in order to serve their customer. What about if Amazon lose 30 minutes or its server is not available for 30 minutes, what kind of losses it will have, what kind of value it will lose. So let me tell you, what is the total, let's say Amazon is $365 billion, their revenue, for very simple calculation. Their annual revenue is $365 billion. For one day, it is $1 billion. For 1 hour, it would be 1,000 million divided by 24. So I just give it, like roughly 24, 1,000. It would be like approximately 4 into this 40, roughly $40 million. For half an hour, let's say 30 minutes, how much it will, if Amazon server is not working for 30 minutes or Amazon website is not working for 30 minutes, it will lose about $20 million. Is it? Therefore, continuity is very important. How you can ensure the continuity, and you can see what are the chances of that service will not be available, because nowadays internet, all these are 24/7 services. How you can provide? So let's say there are 2-3 things. One is, let's say this is the server. You installed 4 servers in parallel, and all are, let's say 90% availability, means they are 90% reliable. 90%. So this is also 90. This is, what are the chances of failure? Chances of failure is 0.1 into 0.1 into 0.1 into 0.1. Now, what is the value? So I just calculate using calculator, and I will show you 0.1 into 0.1 into 0.1 into 0.1. So we get 0.3 times 0 and 1. So this is the chance of failure. All 4 servers will fail. This is the chance, 0.00. Means what is the chance of availability? It's then I subtract with 1. So it is 99.99% chance of availability. Even this is not good number. The reason is this, even this is not the good number, because 99.99 of 365 days, how much it is going to be? Into 0.365. Into 365. Sorry, I did mistake. So 0.9999 into 365. That is going to be 364 days and 9635, point this much. Even this is not good, because it would be like 96% of the day. That means out of 24 hours, half an hour, there is a chances. So Amazon should have 2-3 more, which is just like a 1 minute or less than 1 minute service down during a year. So having multiple independent services to offer customers can have your, you can save the business value, you can save the customers. Because every year I hear that, the Bank of America website is not working, or any website is not working, or due to something. So this is the concept. Now I go back on slide part. Okay, so this is the concept of this, and then contingency table I already. Now we have, based on that, we have decision tree or tree diagram, how you can choose which is the best decision. So here tree diagram is based on contingency table that you can clearly see here. Here, so this is a bond fund, which is this is type of fund. These are the two types of fund, bond and stock. Low and their expense ratio, low, medium, high. So this is a contingency table that has been created, and you can see the 11, 3, this is the number, 21, 23, which is total 44. Now, how you can make the decision tree based on that? First, so these are the 21, these are the 23. So divide 21 divided by 44, 23 divided by 44. So you can select so here this is, you can see here. So this is made here. So this is 100. So bond is 21 divided by 44. Stock 23 divided by 44. And then you just do this. How you do this? You are going to, sorry, here you can see what is the probability of low condition they are bond. So 11 is the value divided by 21, which is the 21 is total. Similarly, what is the condition of medium and B, high and bond? Similarly, you do this. And now based on that, you can see, you can make the tree. Bond low expenses, bond medium expenses, bond high expenses, and so on and so forth. Now the sum should be 1. Now you just multiply, because you remember the conditional probability. Conditional probability, this multiplied by this is equal to probability of V and L. So using the same formula, probability of B and L equal to probability of L condition B equal to probability of L and B divided by probability of B. I'm just writing on the top of. So this is, now we multiply this here in order to get probability of B and L. So probability B is this much, probability of this is this much. So now you get bond and low expense probability is 25%, bond and medium expense is this much, bond and high expense probability is this much, this much, this much, and sum should be 1. Now you can make decision which probability you want to go. This is your first option. This bond and low expense is 25%. This is also 25%. This is the second option. This is the third option. These are the same. So you can do that based on contingency table, and this is called decision tree. And now we come to the Bayes theorem. This is another important thing. Here probability is revised after an event happen. And Thomas Bayes suggested this in 1700. I think, how old, you can say about 300-400 years ago. So revising probability to reflect new probability. If any event happen, then the probability of event is revised and new probability reflect. So one is called prior and the posterior. probability. And you can see very simple formula, probability of B condition A equal to probability of B and A divided by probability of A. So this remains same. And this is, transfer probability of B and A is replaced with this formula. So probability of B and A is reflected by equal to probability of B and A, or A and B same. So probability A condition B divided by probability of B. So using the same formula, we can replace this. And A and B replaced with condition and probability of B. So this is same thing happening that we just saw in previous slide. So, and then if you go further, it is, this remains same and it becomes complex and complex. So you have many events and so basically this is very useful, but it's complexity, and when we don't have software, we have to create multiple. So we don't have an exam, and but it's important. This is based on conditional probability. So this is based on, decision tree. You can come up with different probabilities. Now we have another important thing, counting rules. And counting rules, like we all remember, how the number plates are assigned for cars in Washington state. And they say 3-digit of A, B, C, and 4-digit of 1, 2, 3, 4. How many number plates can be assigned with this? 26 multiplied with 26 multiplied with 26 means how we can assign the SQ code for different batch of the production of any item. 10 into 10 into 4 times 10. So these many numbers SQ can be, if you are producing any product or iPhone or anything, how you can decide how many alphabets, how many numbers can be there. You can decide it's a million batch product or some. So this is basically used in SQU. Now, another thing, so labeling or SQ, factorial. What is factorial? It is commonly used in this part, this, distributions, discrete and discrete distribution. We did all by Minitab, but if you look into the formula, they are there. What is the factorial 3? 3, 2, and 1. We don't multiply 0, otherwise everything. So go up to 1. Factorial 5 equal to 5, 4, 3, 2, 1. So this is the meaning of factorial. This is 6. This is 120. Now we come to the permutation and combination. Permutation and combination. You can see this is a permutation, that NPR and N factorial N divided by N minus R. So here numerator is less. So permutation is more, combination is less. So this is a combination. And actually it can be very easy if you have if you want to select a team, if you are traveling with 20 players to play a match against any other university, and you need final 11, how many unique combination can be there? So this is one thing. How many unique combination can be there? Another thing, in permutation, how many permutation, how many arrangement can be possible? So this is permutation and combination, and I usually do using this uh, calculator. So here permutation and combination I just do. So 20 and then 11. These many permutation can be there. Now I go again, or let me make a very simple maths. I go under probability and permutation. Let's say I go 5. I think I made. So this is a calculator we use to teach for undergraduate students. Oh, I made mistake. So I think I am writing correctly. Oh, yeah, wrong. So probability, and then I need 3 permutation out of 5. And how many? I think I'm doing something wrong. So math and I think I'm just typing. So without practice and PR. Okay, R is yeah. So this, out of 20 players, you are going to make 11 member team. This could be the same thing. I'm just going to do for combination. How many combination can be created? 20 and 11. These many combination can be created. So permutation and combination is another thing that is useful in this chapter. However, we will not have the questions in the final related to this, just to understand this part. So this is about chapter number 5 and module 1. So you can kick off this course. It is not loaded. It is not a heavy chapter, because some of you are new, so that you can have the mini tab on your computer. And next week we will start the mini tab based learning, 2 sample hypothesis tests. If you have any question, please feel free to ask. Any question if you have, please. Otherwise, we will see each other on next Tuesday at 6 o'clock.
Thank you.
Thank you. Bye-bye. Good night.
Thank you.
Thank you.
Thank you. Yeah, please. Do you want me to stop recording, or it is related to the subject, or it is related to something? If related to subject or learning, I can keep recording on. Otherwise, you can type in the chat box. Please type in chat box. I'm just stopping the recording so that